our linear function is this guy. What's the middle one? What's this guy right here? It is a quadratic. U-shaped parabola, and this guy over here is an exponential. We'll do some exponential stuff in just a minute here, just to get those shapes in your brain. It's helpful. What is the equation of the line graph below? Okay, our easiest way to write an equation of a line is y equals mx plus b. So to find the slope, we need to count. And the first thing I notice is this is a downhill slope, so I'm going to go ahead and make that a negative so I don't forget that later. And this is down to right 3. Remember, we always run right. We let our line tell us whether to go up or down. And since our line is going down, we're going to go down. So it's negative 2. We have 1, 2, 3 boxes this way, negative 2 over 3. And then our y-intercept is going to be plus the y-axis. Here, that's positive 5. That is the easiest way to write that equation. If you have the y-intercept, y equals mx plus b. Done. Next, the following formula can be used to describe the height of a tree. Okay, so here's our equations. I like these. Before I even read what it's asking, I'm going to go ahead and label some things. So this is the slope. This is the y-intercept. And the y-intercept is also, like, if we're doing a word problem, I would probably even label that differently. I would probably label that starting amount. All right, so at what rate is the tree growing? Well, remember, rate is another word for slope. So our rate is 0.5. Now we probably want to be able to pick units. I can definitely see the OST putting units, like making this a multiple choice problem and having units be part of something that you need to deal with. So when we're doing units, we need to do our y over our x. And remember, our x is usually time. So our time unit here is months. And our y unit here is feet. So I'm going to make that a little prettier. 0.5 feet per month. Now, I think that you could probably read that and tell, like, if they made it like month per foot, hopefully you would be like, yikes, that sounds super weird. But I can definitely see that as a multiple choice problem. How tall is the tree when it was planted? Well, that's our starting amount. 3 feet. We're in feet here. Make sure you're including units, just in case units are a thing on the test. How tall will the tree be in 1 year? Well, we're in months here, so 1 year is going to be 12 months. So our equation looks like this. And that's our number of months. So I would put 12 in there. And this is what I would write on my scrap paper. I would not type into Desmos until I write something on my scrap paper, even if it's just to focus me in or help me process the problem a little further. We talked about using scrap paper all year long, but this is where you really want to be practicing using scrap paper on every problem. Write something down. Did anybody put that in to a calculator? It's nothing. So 9 feet. And how many months until the tree is 20 feet tall? You have a couple of options here. You can do this. 20 equals 0.5 m plus 3, and you can solve for m. Desmos, and you can figure out, looking at the table or the graph, you can figure out where your y is 20. Let me show, I would probably use the table. So let me show you that really quick. Remember, Desmos is not going to like that m if you put it in. So I would not put in the m. I probably wouldn't even do the function notation. I would just do 0.5x plus 3. And then you could look at the graph, but what's more helpful for me, I think, is to pull up that table. And 20 would be your y, so it would be this. So what you can do to figure out what x is going to be when y is 20 is just get in your table and go. It's going to take a while because it said our answer was actually 34. I don't know why it does this period. It never does it in another period. And just keep going. So you're just hitting this blue down button to give you your next. So it's going to take a while. Your y or your x is going to be 34. That's probably the least work there. I'm going to give you the path of least resistance there. 34. So that's lines. A little bit of lines review. Now let's look at exponentials. Exponential functions are these curves. They can either increase or decrease. They do have a horizontal asymptote, which means they just have a line that they're flattening out at, but they do not touch or cross. That guy's an exponential. Identify each part of the exponential function. Remember, with exponentials, we have a different order than with lines. The number in front is our y-intercept, or our starting amount. The number behind is what we're growing or decaying. That's your rate. That's what you're multiplying by. I actually don't like using rate because that's when they get sloped. So that's what you're multiplying by. And again, y-intercept, you can still think of starting amount. Still think of starting amount. So for this one, our y-intercept is 4. And since we're multiplying by 1/2, since 1/2 is less than 1, this is a decrease. The other way, if you don't remember, if you have a problem that is maybe as kind of simple as that, and you don't remember, put it into Desmos. 4 times 1/2. But remember, you have to do to the x. And look at it from left to right. First, here's the y-intercept. Lovely, it's 4. Then it's going down from left to right, so that is a decrease. Okay, you don't have to have it memorized, you just have to be able to figure out the information there. The thing that I always remember when I'm looking at these, if I can't remember where the y-intercept is, the number that's attached to the x, that's what you're multiplying by every time. So just like with lines back here, our number attached to our variable, that's the slope. That's what we're adding every time. Well, same idea here. The number attached to the x, that's what we're multiplying every time. So we're increasing here because we're multiplying by 3. And we're starting with 6. So if you can't decide, a couple ways you can do it. One, remember that x is attached to the number that you're either multiplying by for exponentials or adding for linear equations. The other thing you can do is put it into Desmos. Desmos will show you the y-intercept. Okay. Exponential model, so we're doing percent change here. Remember, percent change is how far we are from 100%. And once we're looking at an equation, our equation is in decimal form. So our starting amount is going to be our number in front. Here we're multiplying by a number that's bigger than 1, so this is going to be an increase. And if you would like, I like to change that 1.97 into 197%. That's quite a percent change. So that's a percent increase of 97%. We're 97% away from 100. Our starting value for 7 is 14. Since our number attached to our x here is less than 1, this is a decrease. So the first thing I'd like to do is change that into percentage form. And then how far is 70 from 100? You can just do a little subtraction problem. It's 30% away from 100. The last one here, we're starting with 78. 0.97 is less than 100, or less than 1, so this is going to be a decrease. I'm going to change it into decimal form. I'm sorry, change it into percentage form. And I'm going to subtract the bigger number from the smaller. 3% change. Percent change is just how far are you from 100. All right, last one. Biology classes at Hayes are studying fruit flies. They start their observation with 60 flies and know the number of flies will triple each day. So start with 60, triple. If we're tripling, that's multiplied by 3. So this is an increase. I like to do a little model setup for myself. And then put my numbers where they go. If I want to start with 60, the 60 has to go in that front blank. If I want to triple, then this needs to be a 3. If I was doubting myself about whether I have the right starting amount, I would put it into decimal. 60 times 3 to the x. And then I would have to zoom out a lot. But, hey, that's start with 60. You could also go ahead and pull up that table. Start with 60. 60 times 3 is 180. I'm feeling good about that. And just make sure your table matches the equation that you meant to write.